Thank you so much for tuning in to watch this talk, and thank you to RailsConf for having me. This is actually the very first conference I've ever spoken at, so I am thrilled to be able to share with the Rails community something that's very close to my heart. A little bit about myself. My name is Ryan. I am a second career developer from Fort Worth, Texas. And some of the things that I like about Texas would be summed up in this one image here. I absolutely love the food here. Um, if you're ever in Texas, I highly recommend the barbecue. It's pretty hard to find bad barbecue, honestly. But yeah, we have some great Mexican food as well. So definitely check that out. This is also the state where I met my wife. This is a picture of us in high school. And I have a very intense look on my face here. Let me put up a recent picture. There we go. Clearly, we have matured. So I mentioned that I am a second career developer. My first career was as a designer. I was a designer for 15 years, and those 15 years can be summed up in one image. So that was basically how that went. But luckily, I eventually made the jump to development, and now I help make the space that comes from the Container Store. And more specifically, I work on our e-commerce website. One of my passions is front end development, and I absolutely love it. I love it because it's one of the first layers that users encounter on the web. And a big part of front end development is ensuring that the UI that you build is accessible, that it can be used by everyone. Uh, so, in order to learn more about that, our team invited a special needs teacher to share how her students use accessible technology on the web. And, I've been building websites for quite some time, a lot longer than I've been at the Container Store. So I thought that I knew how to build accessible UI. But after her presentation, I realized how uninformed I really was. And that basically led to this talk. Before I go any further, I want to get this out of the way. This isn't a Rails talk, but it's Rails adjacent. This talk is about an idea. It's an idea that Sir Tim Berners-Lee had when he invented the web 30 years ago, and it was an idea to create a community that openly and freely shared knowledge that anyone could access. The problem is a lot of the content on the web now is inaccessible, and it's getting worse. WebAIM, a nonprofit organization specializing in web accessibility, conducts yearly surveys of the top 1 million home pages. In last year's survey, they found almost 61 million errors, accessibility errors, and that's up 1.2% from the previous year. It's important to note also that this survey utilized automated accessibility testing, which doesn't really catch all of the errors, so the picture is probably much worse. I want to talk about how we as developers can help solve this crisis. First, let's talk about what I mean whenever I say accessibility. Simply put, accessibility is about removing obstacles to ensure everyone has equal opportunity to participate, and that word equal is very important. And when you're talking about accessibility on the web, that means building websites, applications, tools, and technologies in a way that allows everyone to participate and contribute equally. So if you build anything for the web, this should matter to you. It should matter because, first of all, it's the law. In the US, the Americans with Disabilities Act prohibits discrimination on the basis of disability. And even though the act was passed before the wide adoption of the internet, websites have been declared subject to the ADA as places of public accommodations, and other countries have passed similar laws. This past year, we've seen people rely more and more on the internet to get things done. And as a result, we're seeing a rise in ADA-related digital lawsuits as well. There were 3,550 new ADA lawsuits in 2020, and that's up 23% from the previous year. So you can definitely see a trend here. Accessibility also matters because it can be good for your business. The CDC estimates 61 million Americans, that's 1 in 4 US adults, have a disability that impacts their major life activities. The Nielsen Company calls this group one of the most present and perhaps most overlooked segments of the US consumer, and it's a segment with over $490 billion in disposable income. You can see how important it is to cater to this community, and it can actually become a unique marketing opportunity. Another reason accessibility matters is that it makes things better for everyone. You can see this in real life. Curb cuts were originally introduced at Berkeley to allow wheelchair users to cross the street without any additional help, but they also benefit parents with strollers, travelers with luggage, and children on skateboards and scooters. Accessibility on the web similarly benefits all users. The more accessible you make your website or your application, the easier it is for everyone to use, especially when you consider what people are experiencing when using your app or site. There are temporary disabilities like broken limbs and distracted drivers and people in noisy restaurants that may have a hard time hearing. And even old age brings with it a decline in ability. Finally, accessibility matters because it's an essential right. We have an ethical responsibility to ensure all content is made available to as many people as possible. This was the original intent of the web. So now you know that accessibility matters, but maybe you're like I was in that teacher's presentation. I was completely unaware of common issues and I didn't even know where to start. So I ended up at the Web Content Accessibility Guidelines, or WCAG for short. It was created with the goal of standardizing web content accessibility. And actually, it's about to be expanded to include accessibility for all digital content whenever it changes over to version 3.0. The current version 2.1 has 3 levels of compliance. There's 1A, which is the bottom tier, and that's your basic accessibility, right? Level 2A has been considered the legal requirement. That is the middle tier, and then 3A is the gold standard. It's the top tier. WCAG also uses 4 guiding principles to define accessible content, and they are perceivable, operable, understandable, and robust. A convenient way to remember these principles is the acronym POUR. So let's take a look at POUR content in action. The first principle, perceivable, it means that content should be able to be recognized by any of the available senses, and that means that anything that's on the screen not only has to be seen, but heard and even felt if necessary, and we'll talk about that more in a minute. The first example we'll look at has to do with color. Improper contrast is one of the most, if not the most, common accessibility error, and it's probably the easiest to fix. In this example, which is in Chrome, we have 2 different blocks of text, one that's smaller and one that's large. Let's go ahead and inspect this in Chrome DevTools. You can see that we get a color swatch here that we can click, and then you see that the contrast ratio is 2.59. That means it's 2.59 times darker than its background, but it needs to be 4.5 times. So one way we can fix this is if you see these lines here, this is 2A compliance and this is 3A compliance. We're going to drag the color indicator just below the 2A line. And now you can see that it's fixed. So we'll go ahead and close that to save the color. Now let's inspect the large text. We'll go ahead and bring that up, and you can see in the palette that it again has 2.59 contrast ratio. Well, since this is larger text, we just need a 3.0 contrast. We can go ahead and click the suggested color swatch and then close that palette. And now we've fixed the color contrast issue. This is actually something that you would want to bring up with a designer. And honestly, this is something that a designer should already be designing for. But you should always, if you're developing, always check to make sure that the colors have the proper contrast. Like I said earlier, content should be able to be heard and even felt. Well, one of the main things that accessible technology does is it transforms one type of content into another. Screen readers transform text into audio content. Braille displays transform text into content you can actually touch. And we even have software that can automatically transform audio content into captions. But these technologies still need help. For the next few examples, I'm using VoiceOver, the screen reader that comes with macOS, as well as the Safari web browser.
VoiceOver on Safari. Alt text example vertical line 11Y demos. Window. Alt text example vertical line 11Y demos. Web content has keyboard focus.
So we just turned on VoiceOver, and it tells us some information. First, it tells us what application we're on. So screen readers aren't just a web technology. They're an accessible technology for your entire operating system, so they need to be able to tell you what application you're on. The next thing that it tells us is the name of the window, which is alt text example. And then it tells us what has keyboard focus, which is the web content inside of alt text example. Let's go ahead and jump into the content and see what everything else sounds like.
In alt text example vertical line 11Y demos. Web content. Main. Heading level 1. Alt text. With alt text. Figure. You are currently in a figure.
So the first thing it does is it focuses onto a main element. The main element is a semantic HTML element that defines the main content of a web page. And that's basically how a screen reader can identify what the main content of a page is. The next thing that we hit is the alt text heading. And then we jump to a figure, which is where we are right now. A figure is another semantic HTML element that defines a group of content that represents something. And inside we have a caption with alt text. That caption is wrapped in another semantic HTML element called fig caption. And that just defines a relationship between that caption and the surrounding figure. So we'll talk more about semantic HTML elements in a minute. But for now, let's see what images sound like in a screen reader.
The top of the Chrysler building against a cloudy sky. Image. You are currently on an image.
So when we focused onto the image, it told us that we were on an image, but it gave us a description of the image. So how does the screen reader know what this image is? We've actually added alt text to this image. Alt text is a short description that, it describes what the image is. There are a lot of rules around what makes good alt text, and I highly recommend you checking them out. It's fairly easy to search and find a lot of great content online. But the important thing here is that you add an alt attribute to your images, always. When you don't have an alt attribute on your image, it can sound very confusing.
Without Nicole Padine BJY to Amelie on splash JPG. Image. You are currently on an image.
So it reads off the image source, which in this case is just a bunch of different letters strung together. It doesn't really make sense at all. So always include an alt attribute on your images. If your image is purely decorative and you don't want it to be announced to a screen reader, then include a blank alt attribute. And in fact, you might want to think about adding those images as background images. That way they're not read by the screen reader at all. Finally, let's take a look at icon buttons. Screen readers can announce button labels if they have text inside, but what if they just have icons? In this example, we have a button with only a hamburger menu icon visible. Let's hear what this button sounds like.
VoiceOver on Safari. In menu example heading. Navigation menu. Collapsed button.
So this is a button to open up a menu. And right now you can see that there's actually a label associated with it, navigation menu. So how does the screen reader know what that label is? Well, we're adding it with a visibly hidden label. So this span here has the class SR only, which is a class that visibly hides text, but still exposes it to the screen reader. Another thing that we're also doing here is hiding the SVG from the screen reader to make sure that it doesn't announce anything inside of the SVG, because you can have things inside of an SVG that can actually be read by a screen reader. Another thing that we have to do is add focusable equals false because of a bug in Firefox that actually focuses SVGs. And any content that's focusable should be interactive. And for the most part, SVGs are not going to be interactive. Without a label, buttons, again, provide no useful information to screen reader users. In this example, I've removed the label, and here's what it sounds like.
Collapsed button.
So no label at all. If I'm just using a screen reader, I don't know what this button does. Here's a look at that SR only class that hides the text visibly. It's using a combination of clip path and position absolute to visibly hide the text, and also to remove the text from the document flow so it doesn't take up any visible space. Now that we have perceivable content, we need to make sure that our content is operable. That means people should be able to interact with content in a variety of ways. Content should support different inputs like mouse, keyboard, touch, and voice, as well as different contexts like a desktop screen with magnification software or mobile devices. Full keyboard support is critical to supporting the widest variety of devices, so let's look at that first. For the next few examples, I'm going to be using the Ruby on Rails repository on GitHub, because GitHub really does a good job of providing good keyboard interaction. So we're going to start navigating using a keyboard on this page, and you can see the first thing that pops up is a skip to content link or skip link. Let me tab through again so you can see all of the different things that you can interact with in this toolbar. Now I'm going to go back to the skip to content link and activate it. Now I'm going to start tabbing again, and you can see I've skipped completely the entire toolbar. So this is a great pattern, especially if you have a lot of content in your header. Even if you don't, I would say that this is a great pattern to use for any website or application, unless you just have a super simple site. You may have noticed also that as I tabbed through the page, you could see where I was on the page thanks to the focus style. So the focused element is styled to allow me to know where I am at all times. On this page, I've completely removed the focus style. And I'm tabbing, and you can't see where I am. So this sort of illustrates the fact that it's very important to keep focus styles. A lot of times designers will want to remove focus styles because they may not look nice, but it's okay to restyle focus styles as long as they are still accessible, at least as accessible as the default focus styles, if not more accessible. Making web content accessible is really about giving people options. And screen reader users have multiple ways that they can navigate quickly through content. In this demo, I'm back on Safari with VoiceOver.
Links menu.
So what I've just pulled up is called the rotor. The rotor is sort of like a command center. It's a collection of different menus. This is the links menu, but we have other menus as well that group certain types of content together and allow a screen reader user to jump through content on the page very quickly. Let's arrow down through all these links.
Visited. Visited. Link. Pull requests you created. Visited. Link. Issues you created. Link. Market. Link. Explore. Visited. Link. Link. Rails. Visited. Link. 2,470 users are watching this repository.
So I'm going to stop right there. There are actually a ton of links on this page, so navigating using links is not going to really save you a lot of time whenever you have a lot of links on a page. But I did want to show this one thing here. You can see where focus is on the page currently. It's on a label of 2.5K. And the link text itself is different. It says 2,470 users are watching this repository. And the reason why the link text is different is because it has to capture the context of where the link is. The link itself doesn't have a lot of room there. So they're saving room by abbreviating 2,470. And it's right by watch. So you can tell visibly by the context that 2,500 people are watching this repository. Well, you have to represent that context in the link text itself. So they're doing that here similarly to how we put a label on the icon button. One of the most popular ways screen reader users navigate a page is by heading. Headings are important to breaking up content for clarity, and they are one of the most effective ways to help people navigate complex pages. Let's pull up the heading menu and in the rotor and navigate to the first heading in the README.
Headings menu. Heading level 1 3 items. Rails/Rails. Heading level 1. Welcome to Rails. Heading level 1. Welcome to Rails. You are currently on heading level 1.
So now I'm on the first level heading of the README page. But I really want to get started with Ruby on Rails. So let me see if there's a heading of getting started.
Heading level 2. What's Rails? Heading level 2. Model layer. Heading level 2. Controller layer. Heading level 2. View layer. Heading level 2. Frameworks and libraries. Heading level 2. Getting started. You are currently on heading level 2.
So VoiceOver provides a very convenient shortcut key to jump through or to navigate the page using headings. And I was easily able to jump through all of that content there to find the getting started section. And now I can just read starting from here on down. Very convenient. So another concern for keyboard operability is custom UI. This menu follows the disclosure pattern. There's a button and a hidden panel. The button toggles the panel expanded and collapsed. So I can actually tab to the button, hit return and open and close it, and space and open and close it. I can also tab through the menu content and hit escape to close the menu. These keyboard interactions are standardized in the Accessible Rich Internet Applications Spec, or YARIA. You might remember that ARIA hidden attribute I pointed out earlier. Well, ARIA is a collection of ARIA-specific attributes and roles and relationships that help define patterns for accessible technology users. The YARIA authoring practices is a great place to start for finding details on specific UI patterns. So if you want to know how to build an accessible accordion or tabs or carousel, this is where you go. And they give you all sorts of information like the right ARIA attributes to use, if there are any HTML native elements that you can use, and all of the JavaScript that you need to handle the correct behavior. Now that we have content that's perceivable and operable, we need to make sure that it's understandable. Declaring the page language is one way of making content understandable. The lang attribute, seen right here, is actually set to English on the HTML element, and this attribute is inherited. So every single child element will receive English as its language. If you are including language that is a different language, like a Spanish or French word, then you want to surround that content and set a different lang attribute on that block. The important thing here is that this helps screen readers understand what language they're parsing, so it helps them pronounce the word. Another way you can help make your content understandable is by providing clear errors. On this form example, I'm going to go ahead and hit submit without filling out any data, and immediately I get these errors. So I can see the first error is that my email is required. So let me fill this out. And as I fill it out, I see that the content is now invalid. So let me put a valid email in there. And likewise, let me put a password in the password field. And then I hit submit and success. Screen readers need help associating labels and messages with form inputs. Buttons are labeled with the button element's children, but inputs are a little bit different. Let's listen to what inputs sound like in a screen reader.
Your email. Required invalid data. Edit text. Error. Your email is required.
So it did a few things when we focused this email input. First, it announced what the label of the input is, your email. Then it told us that it was required, and also importantly, it told us that it was invalid. But then it paused briefly, and it told us what the error was that was associated with the input. And the way that we're doing that is, first of all, we have a label element, which is another semantic HTML element, and it has this for attribute that we set to the ID of the referenced input. Next, we have on the input an aria described by, there's another aria attribute, aria described by, and then we're setting it to the ID of the error message container. So when you focus this input, the screen reader will read out the information for the input first and then pause briefly, and then it will read any content that is a child of anything in the description of the input. So right here you see that it is completely blank. This is before we fill out an error, but once an error is filled out, when you focus this input, it will read out that description. Finally, in order for content to remain accessible, it must be robust. Robust content should be accessible to a wide variety of technologies and contexts and remain accessible into the future. And the best way to do this is by using an HTML validator. You need to make sure that you write valid HTML. These online HTML validators are everywhere. This is the W3C HTML validator. All you do is you paste the URL of your website in here and then submit it, and hopefully you get this nice little green message that there are no errors. But if you do find errors, you can easily figure out where those errors are on the page. And this is a great way to prevent some really bad bugs, really bad accessibility bugs especially. Another way to make sure that your content is robust is to make sure that your markup has the proper roles and relationships defined. I talked earlier about ARIA, how it defines these roles and relationships. Well, the best way that you can do this is to use semantic markup. I keep talking about semantic markup, but it is very important. There are actually over 100 HTML elements, and many of them have predefined roles associated with them. There's a joke of name all the HTML elements, and the answer is div and span. Well, I've seen a lot of UI that are made up of just divs and spans, and these elements are completely generic. They really have no semantic meaning whatsoever. You can put semantic meaning on them, but it's a lot of effort, and for the most part, you'd be better off finding HTML elements that do that for you. You also, by using semantic HTML, you get the benefit of not having to reinvent everything with JavaScript. A lot of HTML elements, like button, for instance, button handles keyboard interactions without having to do anything. So it definitely pays to use semantic markup. So an example of this, we've gone back to our little menu disclosure. This first one here, I can open it and close it, but I also have a duplicate one that I've created. Looks exactly the same, but you can see the difference whenever we inspect these menu elements. So the first one here is just a button and an unordered list inside of a nav. And the nav itself is acting as the disclosure, and we're using a lot of JavaScript to do that. But here in this example, we actually have two new elements, a details element and a summary element. So the details element is actually a native disclosure element. So it will hide and show content based on the toggle, which is the summary element. So the summary element is acting as our button here. If you look at the markup side by side, you can see that, the actual HTML, there's actually one more extra element compared to the non-details version, but the big difference comes from the JavaScript. And you can imagine the more complex these elements get, the more it pays to use semantic HTML. Finally, more complex applications may have dynamic updates on the screen. You see this a lot with single page apps, but basically anytime you dynamically update the page, you dynamically make content appear or disappear, you need to let screen readers know. So an example of this might be, I'm on a shopping website and I add an item to my cart, and there's a cart icon that automatically updates to a new cart amount. You need to let screen readers know that that's changed. In this example, we're using our form again, and what we're doing is we're alerting that there are errors present on the form.
VoiceOver on Safari. Form example vertical line 11. Your password. Submit. Button. There are errors.
So there are errors appears on the screen, but it also it's dynamic, and yet the screen reader picks up that text. And the reason it's doing that is because we're using another semantic HTML element, the output element. The output element is a form element that is dynamic. Basically, anything that happens inside of an output element, it gets reported to a screen reader. And that's part of this ARIA specification called live regions. And live regions, there's a lot of complexity to live regions, but basically, at its heart, they watch certain regions of the page, and when those regions change, they let screen readers or accessible technology know. And then that technology can then announce those changes. So we've been talking a lot about WCAG 2A and all these different types of specifications. And I think it's important to let you know that this is just the minimum requirement. Just because we meet a certain specification doesn't necessarily mean that our content is accessible. We're definitely on our way to being completely accessible, but we need something to confirm that. So the best way you can make sure that your content is accessible is through testing, manually testing with real accessible technology users. There are some great case studies out there that talk about how to do this. And there's one article in particular, that second article on the screen, that they used a company called Fable Tech Labs. And all this company does is they will test your content with real accessible technology users. So this is definitely something you want to look into as you're building accessible UI. So at this point, you may be thinking, wow, we covered a lot, and you're telling me that we're just scratching the surface. This just sounds like too much. Let's talk about some ways that can keep you from feeling overwhelmed. One of the best ways to do this is through automation. Automated testing is fantastic. It can help catch bugs, and it can help keep bugs out of your code, but it can also help keep your UI accessible. Integrating automated testing into your CI/CD pipeline can give you important real-time metrics. One of the things, or the strategy that you want to use, is to make sure that you're not adding new violations with every commit, and also you want to make sure, or you want to see if you're reducing violations with every commit. There are some great tools to help you test for accessibility. There are plugins for Cypress. Cypress is an end-to-end testing solution. I highly recommend it. We use it at the Container Store. There's Axe Core, which is a product from DQ. This is the company on the screen right now. Axe Core is a framework that a lot of tools are based on. There are plugins built with Axe Core. Lighthouse, which is Google Chrome's validator, is actually built with Axe Core for accessibility audits. And also, Lighthouse has a great CI solution, Lighthouse CI, so check that out as well. You can scale accessibility with component-based design. Sharing a library of common UI allows you to focus on one element at a time, and any changes to a single component can easily propagate throughout your entire website or application. What you're seeing here is actually from Brad Frost's Atomic Design. And Atomic Design is a component methodology that breaks pages down into a hierarchy of composition. So you break your UI down into simpler and simpler components until you can no longer break them down. And this is a really interesting way of approaching component design. A component solution might look like web components. Web components are basically a combination of different native web APIs that allow developers to encapsulate functionality and markup into a custom element. This is really interesting, and I'm looking into web components right now, but I'm also discovering that there are some rough edges still, and mainly around accessibility itself. But for Rails specifically, Flywheel have written a great article about how they use partials to create composable components. They make use of the cells gem from Trailblazer. Cells are view models that encapsulate all presentation and rendering logic, so it easily encapsulates all of the markup and behavior of a component. That should make it easier to bake your accessibility into these components. Some things you can do to help as you develop are manually test. So install a browser accessibility extension and run it regularly. I am a huge fan of Axe Core DevTools, which is the Chrome plugin for Axe. Out of the box, it can detect 57% of accessibility errors. And there's even a pro version that can detect up to 84% with guided tests. Always test your interfaces with a keyboard. Can you easily navigate? Can you operate the UI without a mouse? This is probably one of the best indicators right off the bat of how accessible an application or website is. I would really encourage you to learn a screen reader. Screen readers, especially to people that have never used them before, they can be very awkward, but don't get discouraged. I highly recommend using them. They really do help you see your UI in a completely different manner. For Windows, you can download and install NVDA, which is a free open source screen reader. And for Mac, I've already talked about VoiceOver. It's built in, it comes with Mac OS. So definitely go and download them or open one up and check it out. Finally, start thinking about shifting accessibility to the left in the process as much as possible. Yes, you need to be thinking about it in design. You need to think about accessibility in development, but you also need to think about accessibility when you're writing feature requirements. And even whenever you're hiring, the earlier your organization thinks about accessibility, the easier it becomes. Look, you may struggle at first, but accessibility is just like performance or security or every other complex subject that developers face. The more you pursue it, the more you learn, the better you will get. Yes, it can be a lot of effort at first, but believe me, the effort is worth it. I mentioned at the beginning of this talk that it's really about an idea. And on the 30th anniversary of the World Wide Web, Sir Tim Berners-Lee wrote a letter looking back at the web's legacy and forward to the web's future. He reiterated this idea as a core truth that the web is for everyone, and collectively, we hold the power to change it. It won't be easy, but if we can dream a little and work a lot, we can get the web we want. Thank you so much for watching this talk. You can reach out to me on Twitter. I'm out at The Real Boone. I write on my personal blog, and you can also follow me on Dev Community. If you have any questions, please don't hesitate to reach out. I hope you enjoy the rest of RailsConf. Thank you very much.